Hello students, look here. Today we will start the part 20 of the integral, and this part is the last part. Okay, and today we will do some important questions. These are very important questions we have. Look here, first question is pi by 2 to pi e power x bracket 1 minus sin x and upon 1 minus cos x and dx. And second question is 0 to pi by 4 sin x cos x dx upon cos power 4x plus sin power 4x. Question number third is 0 to pi by 2 cos square x upon cos square x plus 4 sin square x and dx. And question number 4 is pi by integral of pi by 6 to pi by 3 and sin x plus cos x dx upon root sin 2x. Question number 5 is integral of 0 to pi by 4 sin x plus cos x dx upon 9 plus 16 sin 2x. Question number 6 is 0 to pi by 2 integral sin 2x tan inverse sin x and dx. Question number 7 is integral of 0 to pi x tan x dx upon sec x plus tan x. And question number 8 is 1 to 4 integral of 1 to 4 and modulus of x minus 1 plus x modulus of x minus 2 plus modulus of x minus 3 and dx. Look at these questions are very important, and from these question number 7 and question number 6 these are given many time in a board exam. These all are the board questions, but these are very important. Now we will start this first question. Here e power x means we can use the formula e power x fx plus f dash x and dx, and this is equal to, we all know that this is equal to e power x fx plus c. Okay, this formula we already know, so this we can use here. Before that we have to arrange in a proper way so we can identify fx and f dash x. Okay, so we can write this e power x 1 minus sin x, we can write 2 sin x by 2 and cos x by 2. Okay, and 1 minus cos x we can write here 2 sin square x by 2 and dx. Now we can do separate. So when we do separate, we get integral pi by 2 to pi e power x 1 upon 2 sin square x by 2 and minus 2 sin x by 2 cos x by 2 upon 2 sin square x by 2 and dx. Okay, look here 2 to cancel, sin x 1 cancel, so we will get here pi by 2 to pi e power x, this we get 1 upon 2 cosec square x upon 2, and we get here minus, this will be cot x. Okay, this will be cot x by 2, cot x upon 2 and dx. Okay, now we will get here cot x by 2, this is here fx, so we can write here this fx is equal to minus cot x upon 2, so f dash x equal to cosec square x by 2, actually the cot x by 2 differential is minus, so minus plus we have, and x by 2 differential is 1 upon 2, so we get this. So this question is change in pi by 2 to pi e power x, and here is fx plus f dash x and dx, and this equal to, we know already, and this is equal to a power x fx and pi by 2 to pi. Look here this we can write e power x and fx is minus cot x by 2 we can write, and pi by 2 to pi. Now place of x we can put pi, so we get here minus e power pi cot pi by pi upon 2 and minus plus, then we will have here e power pi by 2 and cot pi by 4. Okay, now look here, we can write the value of cot pi by 2. Cot pi by 2 is actually 0, so this will be 0, and e power pi by 2 and cot pi by 4. Cot pi by 4 is 1, so we have here 0 plus e power pi by 2 means we can write e power pi by 2. This is our answer. All of you understand this? Look at next question is 0 to pi by 4 sin x cos x dx upon cos power 4x plus sin power 4x. Look here numerator and denominator divide by cos power 4x. So look here 0 to pi by 4 this integral and sin x and cos x and divide, we can write here cos power 4x. Whole divide this also we divide by cos power 4x, and this cos power 4x we can separate cos power 4x and dx. Okay, and this we can write 0 to pi by 4. Look here 1 cos is cancel here, and sin upon cos is we can write 10x, and 1 upon cos square x is remaining, this we write sec square x, and dx is as it is. And denominator we can write this is 1, and this we can write 10 power 4x, and 10 power 4x we can write 10 square x and whole square. All of you understand this? Now we will suppose 10 square x equal to t. So we get here 2 10x, and 10x differential is sec square x dx equal to dt, and we get here 10x sec square x dx equal to 1 upon 2 and dt. Now we change the limit we have to change. When x equal to 0, then 10 square 0 will be 0, so this is t. Now we have x equal to pi by 4, so we have here 10 square pi by 4, and 10 square pi by 4 is equal to 1, so this t equal to 1. Now this all we change, so 0 is 0 only we have, and pi by 4 means we have 1, means now the question is integral 0 to 1 10x sec square x dx, we can write 1 upon 2 and dt, and here we can write 1 plus t square, and it is a very simple formula. This is a formula for 1 upon 2 tan inverse t. Okay, and here 0 to 1 means we can write here this place of t plus 1 and minus tan inverse 0, and tan inverse 1 we know already, this is pi by 4. Okay, and minus 0, so the answer is pi by 8. This is our answer. All of you understand this? Look at the next question is integral 0 to pi by 2 cos square x dx upon cos square x plus 4 sin square x, and here also divide numerator and denominator divide by cos square x. Okay, so look here what we get here 0 to pi by 2, and this we divide by cos square x, we get here 1 and dx as it is, and here we divide by cos square x, we get here also 1, and here we divide by cos square x, we get here tan square x. Okay, now here also we will suppose the tan x equal to t. So look here, this suppose tan x equal to t means we get here sec square x dx equal to dt, and sec square is not present here, so we will transfer this sec square x in a right hand side, means you can write dx equal to dt by sec square x, and this sec square x we can write here 1 plus tan square x, and place of tan x we can write t, so you can write dt upon 1 plus t square. All of you understand this? Now we have to change the limit also. So here limit is first x equal to 0. If we put x equal to 0 means we get tan 0, and tan 0 means we get here 0 equal to t, and now we will put x equal to pi by 2. If we put pi by 2 means tan pi by 2, and tan pi by 2 is here infinity, so this t will be equal to infinity we get. So these value we will put here, we get here 0 to infinity, and look here place of dx we have to write dt upon 1 plus t square, and place of this we write 1 plus 4 t square. All of understand? Now we will do the partial fractions. So you can write here 1 upon 1 plus 4 t square and 1 plus t square, write separate. We will use here partial fractions. And this t square, here t square always, so t square is act as a t, and we can write here a upon 1 plus 4t whole square, and the second we can write b upon 1 plus t square. Now we will take the LCM, so we will get here 1 upon 1 plus 4t square, 1 plus t square, and here LCM is 1 plus 4t square is LCM here, this LCM. So we can write a into 1 plus t square, and place of this also we multiply 1 plus 4t square. LCM and LCM is cancel, we get this equation, and here we will put place of t square equal to minus 1, place of t square minus 1, which is 1 equal to place of t square minus 1, this will be 0, and here we will put t square is minus 1, so we get minus 4, and this will be 1 equal to minus 3b, so this b equal to we get minus 1 upon 3, and same as it is we can put here t square equal to minus 1 upon 4, t square equal to minus 1 upon 4, this portion will be 0, and we get here 1 equal to a 1 minus 1 upon 4, and here this 1 equal to 3 by 4 into a, so a equal to we get 4 by 3, and these value we will put here, so we will get here 1 upon 1 plus 4t square and 1 plus t square. This we can write place of a we write 4 by 3, so 4 by 3, 1 upon 1 plus 4t square, and place of b we can write 1 upon 3, this so we can write here 1 upon 1 plus t square. And now we have to do the integral we can do, and here is the dt, here is also dt, here is dt, and this limit is 0 to infinity, so this will be 0 to infinity, limit is 0 to infinity, we can write here integral of this integral 0 to infinity 1 upon 1 plus 4t square, we can write here 0 to infinity and dt upon 1 plus this we can write 2t whole square, okay, and 1 square, minus here also this we write as it is 0 to infinity and dt upon 1 square plus t square, and we know already the formula for this is tan inverse, okay, so 1 upon a is here 1, tan inverse we have x by a, x is here 2t and a is 1, and because of this coefficient of t is 2, so we have to divide by 2, minus, and here this limit is 0 to infinity, minus 1 upon 3, this is formula for tan inverse t, and here is limit is 0 to infinity. This will be we can cancel 4 and 2, so we get here 2 by 3, and tan inverse we can write here 2 into infinity is infinity, minus tan 0 we can write minus 1 upon 3, and here we can write tan inverse infinity minus tan 0, and look here, this is 2 by 3 and this will be here pi by 2 we can write, and this is 0 is 0, minus 1 upon 3, and this also we can write pi by 2. Now here LCM is 6, we can see here 6 is LCM, here is 2 pi and here is pi, so we can write answer is pi by 6, so this answer we get here pi by 6. Look at this question, here integral pi by 6 to pi by 3, in numerator we have sin x plus cos x and dx, and in denominator we have root of sin 2x. Look here, the denominator we have to arrange in this format, that if we do the differential of that part, and differential we get sin x plus cos x. So look here, actually we want here sin x minus cos x, okay, and this we will suppose here t. Look here, sin x differential is cos x, and cos x differential is minus sin x, minus plus sin x, and dx equal to dt. So look here, Place of sin x plus cos x dx we can write dt, and in denominator we can write t. But look here direct given sin 2x, and sin 2x we can write 1 minus sin 2x. This look here, you open the bracket, minus minus plus, and 1 cancel, we get sin 2x. Look here, this 1 minus this 1 we can write sin square x plus cos square x, and sin 2x we can write 2 sin x cos x. Okay, so we can write this is a sin x minus cos x a whole square. All of you understand? Place of sin 2x we can write this part. So the question will change pi by 6 to pi by 3, and sin x plus cos x and dx. Here we can write 1 minus sin x minus cos x whole square. Now we have to change the limit also. Look here, if we put here x equal to pi by 6, here we put pi by 6, we get sin pi by 6 minus cos pi by 6, and this is equal to t. Sin pi by 6 means sin 30. Sin 30 is 1 upon 2, and cos 30 is root 3 by 2. Look at here, root 3 by 2 is more, so minus you take common. So we get root 3 by 2 minus 1 upon 2, and this is equal to t, and we will take this as a. Okay, this a we will take. Place of root 3 by 2 minus 1 by 2 we can put here a. So we can write here, put root 3 by 2 minus 1 by 2 equal to a. This a we can put. Similarly we will put here x equal to pi by 3. So if we put here pi by 3, we get here sin pi by 3 and plus minus cos pi by 3, and this is equal to t, means we can get here sin pi by 3 means root 3 by 2 and minus 1 upon 2, and this is t, and this is we already suppose a, so this we write a. Okay, so look here, this limit is changed. Pi by 6 we put, then we get minus a, and pi by this we get a, and this sin x cos x dx equal to we get dt. So this is dt upon root 1 minus t square, and this is a standard formula of sin inverse t. This is standard formula, and now we put the limit sin inverse a minus sin inverse minus a. And in sin inverse, if we take minus outside, we get here this sin inverse a, and we can write minus 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 plus sin inverse a, and sin inverse a and sin inverse a we get 2 sin inverse a, and place of a we can put the value. Place of a we can put here root 3 by 2 minus 1 upon 2. So we get this is a answer. All of you understand, this is answer. Look at this question, integral 0 to pi by 4 sin x plus cos x upon 9 plus 16 sin 2x and dx. Here this question is same as the previous question we have done. This sin x minus cos x, we have to suppose there t. So sin x differential is cos x, and cos x differential is minus sin x minus minus plus sin x and dx equal to dt. Now look here, sin 2x is given, and sin 2x again we can write 1 minus sin x, sin 2x. Okay. We can write here 1 minus bracket sin square x plus cos square x, and minus 2 sin x and cos x, and this we get here 1 minus sin x minus cos x whole square. Look here is given 9 plus 16 and sin 2x. So look here, 9 plus 16, and place of sin 2x we can write 1 minus bracket sin x minus cos x and square. Open this bracket, we get 9 plus 16 minus 16, and sine x minus cos x whole square. This we can write 25 minus 4 bracket sine x minus cos x and whole square. Okay, this we can write. So place of 9 plus 6, this we can write here 0 to look limit also we have to change, and if we put here x equal to 0, x equal to 0 means sine 0 is 0 and cos 0 is 1, so minus 1 equal to t. And if we put x equal to pi by 4, and look here, we know sine pi by 4 and cos pi by 4 are equal, so 0 equal to t we have. So look here, if we have 0 means we have here minus 1, and if we have pi by 4 means we have 0, so minus 1 to 0 we can write. And look here, cos x plus sin x dx, this will be dt. And 9 plus 16 sin 2x we can write here 25, and minus bracket 4 sin x minus cos x and whole square. Okay, now place of this we suppose here t, so this question will be minus 1 to 0 and dt upon this 25 we can write 5 square, and this we can write 4t whole square. And this formula we already know, dx upon a square minus x square, we can write 1 upon 2a log a plus x and a minus x. This formula we can use here, so we will get here that 1 upon 2a is here 5, and log a plus x, a is here 5 plus 4t, and 5 minus 4t, and because of the coefficient of t is 4, so we have to divide by 4, so we will get here 5 to the 10 and 1 upon 40, and your limit is minus 1 to 0. So 1 upon 40 and log we get here 5 plus 40 upon 5 minus 40, and the limit is minus 1 to 0. First we put the limit is 0, so here is 0, here is 0, means we get 5 upon 5 means 1, and minus then we put here limit is minus 1. So 5 minus 4 is 1, and here is 5 plus 4 is 9, this, so we get 9. So we can write here 1 upon 40, and here is this 0 minus, and you write this 9 above, means you can write log 9 power minus 1. This minus we take here, so we get 1 upon 40, minus minus plus log 9 we can write. So this is our answer. All of you understand this? Look at this question, 0 to pi by 2 integral sine 2x tan inverse sin x and dx. Here sine 2x we can write here 2 sin x and cos x. Okay, 2 we write outside, sin x cos x and tan inverse sin x. Now here sin x differential is present, so we can suppose here that sin x equal to t. Okay, so cos x dx equal to dt. Now we change the limit, is here x equal to 0, x equal to 0 means the t will be also 0, and if x equal to pi by 2 means sin pi by 2 is 1, so t equal to 1 we get. Now we change all this, 0 means 0 and pi by 2 means we get 1. Sin x we are writing t, and cos x and dx we will write here dt, and tan inverse we can write here t. Okay, now we will use the integration by parts, and there we will use, this is a first and this is second, so we can write here 2 and bracket, first is tan inverse t, then integral of t dt, and minus integral differential of tan inverse t, and integral of t and dt and whole dt, and the bracket close, and limit is 0 to 1. Now integral of t is t square by 2 and tan inverse t we can write as it is. Now differential of tan inverse t is 1 upon 1 plus t square, and integral of t is here t square by 2. So we can write here t square upon 2 and dt, okay, and 0 to 1. Now we can write here this 2 and t square upon 2 tan inverse t minus, look here, this 1 upon 2 we can write outside, and here we can write 1 plus t square and minus 1. Okay, 1 we add and 1 subtract. 1 plus t square and dt, and now we will do the separate. So we can write 2 and t square upon 2 tan inverse t minus 1 upon 2 integral. Here we can use another bracket. We can write, if we divide this 1 plus t square by 1 plus t square, we get 1, and minus 1 upon 1 plus t square and dt. Okay, now 0 to 1. Now look at this 2 and 2 we can multiply this, so we get t square tan inverse t, and this also we multiply, we get minus, and here is bracket, and 1 integral is t, and this integral is tan inverse t. Okay, bracket close and 0 to 1. Now first we put here 1, so we will get here 1 square is 1 and tan inverse 1 minus t is here 1, then minus minus will be plus, and tan inverse 1 we get, and 0. If we put 0 here, this will be 0 0 0, we get all the 0. Tan inverse 1 we get pi by 4 and minus 1, and here is also pi by 4, and pi by 4 and pi by 4 we get pi by 2 and minus 1. So this is our answer. All of you understand this? Look at this question, 0 to pi integral x tan x dx upon sec x plus tan x. Look here we will use first 0 to a f x dx equal to we can write 0 to a f a minus x dx. Okay, this formula we will use here, and this we write as a I. Okay, so I equal to, we can write here 0 to pi, and here we can write place of x pi minus x, so we can write pi minus x tan pi minus x, and here also we can write sec pi minus x plus tan pi minus x and dx. Okay, look here, this we can write 0 to pi, and pi minus x is as it is, and tan pi minus x is minus tan x, and in denominator also we get minus sec x and minus tan x, and from these if we take minus common and cancel, we will get this I equal to 0 to pi minus x and tan x upon sec x plus tan x. Okay, and dx. Okay, after this we open the bracket 0 to pi integral pi minus x tan x upon sec x plus tan x. We open the bracket means pi into tan x upon sec x plus tan x we get, and second part will be minus x tan x upon sec x plus tan x we get. Okay, this is separate, and this is same as the question we can see. So we write this is a I, this is a I we can write, and this I we transfer to the left hand side, so I plus I will be 2i, and here pi we take outside, so we get pi outside 0 to pi tan x dx upon sec x plus tan x. This I plus I we get here 2i. Okay, this we get 2i, and here 2i equal to pi 0 to pi tan x dx upon sec x plus tan x already we have. This we multiply by sec x minus tan x and divide by sec x minus tan x. After these we can write here this multiplies sec x into tan x, we can write sec x into tan x, and minus we write tan square x. So we get here I equal to this 2 we can transfer pi by 2, 0 to pi sec x tan x minus tan square x dx upon sec x plus tan x and sec x minus tan x, we can write sec square x minus tan square x, and the sec square x minus tan square x, we know this is value is 1. So this I equal to, we get pi by 2, 0 to pi, we get here sec x into tan x, and sec tan square x, we can write here sec square x minus 1. Okay, now look at this pi by 2 we get, and 0 to pi and sec x tan x minus sec square x and minus minus plus 1 and dx. These all integrals we have to do. So look at this, we get here outside is pi by 2, this I equal to, and sec x tan x integral is sec x, and sec square x integral is tan x, and 1 integral is x. Okay, and 0 to pi. Now we will put all these value here, pi by 2, and first we put here pi, so we get here sec pi minus tan pi and plus pi, and then we put 0, so sec 0, then minus tan 0 and plus 0. Okay, now we can get here pi by 2, sec pi is here minus 1 and tan pi 0 and plus pi. Okay, so we get these, and minus sec 0 is here 1 and this only 1. Okay, this minus 1 and minus 1, we will get here pi minus 2. So this is our answer. All of you understand these? Look here, one question is 1 to 4, modulus x minus 1 plus modulus x minus 2 plus modulus x minus 3 and dx. This we do as a separate 1 to 4 modulus x minus 1 and dx, and 1 to 4 modulus x minus 2 and dx, and 1 to 4 modulus x minus 3 and dx. Okay, now here this we can check this 1 and 4. Okay, and here we have 1 and 4. Okay, here also we have 1 and 4. Now look at x minus 1 equal to 0 means x equal to 1 only. Here x minus 2 equal to 0 means we get x equal to 2 will be here. Okay, and here x minus 3 equal to 0 means x equal to 3, so 3 is here. Now we will check the sign of these. So between 1 to 4, if we check, if we put 2 here, then we get positive. Okay, here we can check 1 to 2, we can put here 1.5, then we get negative, and more than 2 if we put, we get here positive. Here also we put, if 1 to 3 means you can put here 2, we get negative, and 3 to 4 we put, we get here positive. So look here, we can separate this 1 to 4, we can write modulus x minus 1 and dx, and plus we can write here 1 to 2 modulus x minus 2 and dx, and we can write 2 to 4 modulus x minus 2 and dx, plus we can write here 1 to 3 modulus x minus 3 and dx, plus 3 to 4 modulus x minus 3 and dx. Look here, here in this interval, this is a positive, so write without this modulus, we can write direct x minus 1 and dx, and here this is 1 to 2, this is negative. Look here, this is negative in this interval, so we have to make positive. For that we multiply by minus. Okay, multiply by minus, and 2 to 4, this is positive, so we write as it is 2 to 4, this is x minus 2 and dx, and here this is negative, so we can write here this 1 to 3 minus x minus 3 and dx, plus this is again positive, so 3 to 4, we can write here x minus 3 and dx. Now we will do the integral. So integral of x is x square upon 2, and one integral is x, and limit is 1 to 4. Here we do the integral, minus x integral is minus x square upon 2, and minus minus plus 2, and integral is x. So 1 to 2 we get, and here the integral of x is x square upon 2 and minus 2x, and here is 2 to 4. Okay, then we will have here this minus, so we can write here minus x square upon 2 and minus minus plus, so 3x, and limit is 1 to 3. Then we will have here x is x square upon 2 and minus 3x, and limit is 3 to 4. Now we will put here first 4. 4 square is 16. 16 upon 2 and minus 4, and then we put 1 here, so we get 1 upon 2 and minus 1. Okay, this is first limit we completed. Now 2 minus 2 square is 4. Sorry, 2 square and minus is, so minus 4, and upon 2 here 2 we put, we get 4, and then we put here 1, then minus 1 upon 2, and 1 we put here 2. Okay, then we will put here this 4. 4 4 is 16. 16 and upon 2, and we put here 4. 4 2 is 8, minus 8 we have, then minus. We put here 2. 2 square is 4. 4 upon 2 and minus 2 into 2 is 4. Look here. Here we put 3. So we get minus 9 upon 2. And here we put, we get here 9. Okay. Then we will put here 1. So minus, and 1 we put minus 1 upon 2. And we put here 1 means we get here 3. Then similarly we solve this, so we get here 4 means 4 square by 4 square means 16. 16 by 2, 4 3 is 12, and then minus, we put here 3. 3 square is 9, and 9 upon 2 minus 3 3 is 9. So these type we get, and these we have to solve. So look here, 16 by 2 is 8. 8 minus 4. 8 minus 4 is 4. Then we get here minus 1 upon 2, and minus minus plus we get 1 upon 2. Okay, this is complete solution. Here we get here minus 4 by 2 means minus 2. Minus 2 and 4 is 2. And here we get 2 minus 1 upon 2 is 4. 4 minus 1 is 3 by 2. So minus 3 by 2. Okay. Then here is plus, this is 8. 8 minus 8 is 0. This is 0. Okay, and this is 0, and this will be 2. Minus 2 and minus 2 and minus, this is plus 2. And here is this is minus 9 by 2 and plus 9 by 2 means plus 9 by 2 we can write. This is will be 3 2 just 6. 6 minus 1. 6 minus 1 is 5 by 2. 5 by 2, and outside is minus 5 upon 2. Okay, and here is we can write 16 by 2 is 8. 8 minus 12 is minus 4, and here is 9 by 2 and minus 9. So minus 9 by 2 minus plus 9 by 2 we get. Look here 4 2 2 and minus 4. This we write here 4 2 minus 4 and 2. 1 upon 2 minus 3 by 2, 9 by 2 minus 5 by 2, and 9 by 2 we can write here. This 4 and 4 we can cancel, 2 and 2 we can add, we get 4, and remaining we will take LCM 2. So we get 1 minus 3 plus 9 minus 5 and plus 9. So 9 and 9 we can do 18. 18 and plus 1 19. 19 minus 8 is 11 by 2, and this we take 4 to the 8. 8 and 11 is 19. 19 by 2 is our answer. Hope you understand this. Thank you and nice day.